Hello, everyone. Um, Here we're going to review the practice problems that hopefully you've already done and are ready to check to see your answers are in the ballpark and what you might have to do differently to make them correct. So, first one, we're talking about a bond. We can do it all in one formula, present value, because bond is essentially borrowing money with the idea that you'll pay interest on a regular basis and the maturity value or the amount that was the loan was for at the very end. So in this case, maturity value is $6 million. So our agreement is we're going to pay $6 million back after 20 years. In the meantime, we're going to make an interest payment using the coupon rate, which is in this case 5.4%, and we pay it twice a year, so half of that times the 6 million. So and that gives us 162,000. So when the company borrows the money, they're going to make interest payments $162,000 every 6 months for 20 years and then pay back $6 million. So what is that worth? What does that translate into present value? Because what's that worth now? That's what's going to happen in the future. But what is that? Absent any default in this scenario, okay, we're going to figure out based on a yield of 5% what this would be worth. So this is the formula, present value. All right, we're going to take the yield, divide by 2, half of that because it's for half the year. And then we're going to take the next thing is we're going to take the number of years and multiply by 2. So whatever you divide by here, you're multiplying here. Because everything is on an annual basis. It's 20 years. Coupon rate is is per year. Yield is per year. So we take 20 times 2, that's 40. And then we take our interest payment we calculated already, and the maturity value, the C2. And we get 6,301,233 because we are paying more than the yield needs to be. Where our coupon rate is 5.4. The yield everybody else is paying is 5%, and so our bonds are valuable more than the face value. So it'd be higher than the face value because we're paying more than the yield. All right, next one is loan payment. We have a loan amount of 4.3 million minus 500,000 or 3.8. Interest rate 6.5% over 20 years. So what would our payment be if we made payments on this, equal payments on this for the 20 years, pay it back? And the correct answer would be 344,874.30. You can see the formula here where we use the payment PMT function. We put in there the interest rate, we put in there the term or the number of years, and we put the amount of rate, loan amount. We don't have to adjust anything because this is all done on annual. But when we move to quarterly, we've got to take the interest and divide by 4 and the number of payments or time periods and multiply by 4. So interest rate, this is all an annual, this is 6.5% interest rate per year, so that translates into 1.6 or so per quarter over the same 20 years. And so we would pay 85,000. So we pay quite a bit less, right? Because we're making 4 payments a year instead of 1. And then if we go all the way down to monthly, we're making 12 payments a year. Okay, we take our interest rate, divide by 12, then we multiply our term by 12. We're going to make that payment 240 times rather than 20 times. All right, and 32 times. This is Just one time. Term 4, the amount of payment is D8 divided by interest rate, divided by 12, take the number of years, multiply by 12, and you take the same loan amount as all the rest. So there's your annual, quarterly, and monthly payments. Obviously, the amount of payment you might make goes down, all right, significantly as you go down that chart. All right, moving to the next practice problem. Okay, we're going to buy equipment, $50,000 now and $350,000 in 2 years. So we got 2 payments. So pull that into our present value. Use the yield or the cost of capital or the normal rate at 10%, 2 times. Okay. One's happening right now, and then the other one in the end of those 2 years that you put in there. So that would be worth $289,256. We required by GAAP to calculate that amount and record our equipment at that amount and record revenue at that amount. So it affects both the seller and the buyer. Buyer's going to debit equipment, credit cash for the $50,000, and owe ArcSoft $289. ArcSoft is going to deposit the cash, record accounts receivable for what they have right now has as a loan payable, and record the revenue. Applying the fact that this is got an interest component, it is not exactly $250,000, it is $339,256. After 7 months, the agreement was done on June 1st. So for the next 7 months, we have incurred $16,873.28 in interest expense. We add that to the loan payable or the note payable or the bond payable, whatever we're calling that. So it makes it go up. Here's it added in. The seller, glad to get rid of it, but take that interest revenue and interest receivable as well if they need to collect using some type of agency. And then, of course, there would be depreciation expense where the asset is now owned by Right Now instead of ArcSoft. We would make this same journal entry at the end of the next year and then at the end of 5 months in the last year. Okay, so we have 2 years, 7 months, 12 months, and 5 months. Comes not exactly to $350,000. Okay, because our compounding is a little bit off, right, a few $100s. Okay, so really what we have is 3 payments, but they're not exactly because we accrue the interest 3 times, 1, 2, 3 instead of just 2, and that can make a little bit difference there. So that's how we calculated that. Don't forget to apply the present value to the loan amount because this is an amount we're going to receive in the future. It can't record it at $350,000 even. All right. All right. Although we do calculate depreciation on the whole amount. Don't forget that. And then finally, we have a series of unequal payments, which means we're forced into using the net present value because in year 1, we make $620 and then it goes up by 12%, 12%, 12%, 12%, and then it only goes up by 5%. 5%, 5% for the rest of it. We take our present value, net present value of, put in our interest rate, our required rate, cost of capital, whatever you want to refer to it as, 12%. And then we can highlight all of the cells at once, everything from C32 all the way up to L32. And what Excel is doing when you click on that formula is it's calculating the present value of each of those numbers individually and adding them up. Okay, and that's what it gets: 5,558,000. So we would be willing to pay for this approximately $5 million, a little over about 5,058,000.